Welcome! Today we're going to break down something called elasticity of demand. Now I know it sounds a little academic, but trust me, this is one of the most powerful tools in all of business, and it answers a huge question every company has to face.
Okay, just picture this. You've got a product, you're selling it, and you decide to raise the price. You know for sure that fewer people are going to buy it. That's just basic economics. But here's the million-dollar question. Was it the right move? Is that extra cash you're making on each sale going to be enough to cover all the sales you just lost?
You're basically looking at a giant tug of war. In one corner, you've got higher profits on every single item sold, and in the other corner, you have a smaller number of total sales. Your total revenue is that rope in the middle, and whichever side pulls harder determines whether you just made a brilliant decision or a really bad one.
So how do we figure out who wins? Well, here's our game plan. We're going to start with that big pricing question. Then I'll introduce you to the tool that actually solves it. We'll walk through a real calculation step by step. Then we'll figure out what that result actually means for your business. And finally, the best part, we'll use all of this to find the perfect price.
All right, first things first. To really get a handle on this, we need a way to measure this trade-off. We have to be able to compare the pull from that price hike against the pull from the drop in sales.
And here is the secret. It's not about the absolute numbers. You can't just compare a $1 price increase to a drop of, say, 50 customers. That's like comparing apples and oranges. What we need to do is look at the relative change, the percentage change. A 10% price hike versus maybe a 5% drop in sales. See? Now we're comparing apples to apples.
And that leads us right to the hero of today's story, elasticity of demand. This is the specific mathematical tool that was designed to do this one thing perfectly.
At its heart, that is all elasticity is. It's just a single number that tells you how sensitive your customers are to price changes. For every 1% you bump up the price, what percentage of your sales are you going to lose? Elasticity gives you that exact number.
So here's the formal definition and that formula. Now, don't let the notation scare you off. All this is saying is you take the price, P, divide it by the quantity you're selling, Q, and multiply it by this thing, d prime of P. That's just the derivative of the demand function. It's a fancy calculus way of saying how fast is demand changing right at this specific price point. We use the absolute value bars because we really just care about the size of the effect, not whether it's positive or negative.
Okay, enough theory. Let's make this concrete. We are going to walk through a real example for a company selling, you guessed it, ribbon winders.
And we're going to follow these 4 simple steps. First, we need our demand function written in terms of price. Second, we get its derivative. Third, we figure out how many units we'd sell at our specific price. And fourth, we just plug it all into the formula. Ready? Let's do it.
All right, here are the details. The current price, P, is $70. The company knows its demand equation is P equals 300 minus 0.02 Q. So, step 1, we just do a little algebra to solve for Q. That gives us Q equals 15,000 minus 50P. Step 2, find the derivative of that. Well, that's super easy. It's just negative 50. And step 3, let's find the quantity sold at our price of $70. We plug that in, and we get 11,500 ribbon winders.
And now for the final move. We take all those pieces we just found and pop them into the formula. So that's the absolute value of our price, 70, divided by our quantity, 11,500. And all of that is multiplied by our derivative, negative 50.
You run the numbers, and you get about 0.3. Fantastic! We have a number. But what on earth does 0.3 actually mean for our business?
This is where the calculation turns into strategy. That little number, 0.3, is packed with information, and we're about to unlock it.
It all comes down to this. There are basically 3 buckets your result can fall into. If your elasticity, E, is less than 1, we call that inelastic. That means your customers are not very sensitive to price, and if you raise the price, your total revenue will actually go up. If E is greater than 1, it's elastic. Your customers are super sensitive, and a price hike will make your revenue go down. And if you hit the magic number where E is exactly 1, that's called unitary, and it means you've found the sweet spot where your revenue is maxed out.
So, let's look at our ribbon winders. We got 0.3. Well, 0.3 is definitely less than 1, so demand is inelastic. This tells us that a 1% price increase would only cause a tiny 0.3% drop in demand. In that tug of war, the price hike wins, easily. The clear business decision here? Raise the price.
To make this feel a little more real, just think about onions versus cars. You need onions for dinner tonight.
If the price goes up a few cents, you're still going to buy them. It's a necessity, so demand is inelastic. A car, on the other hand, that's a huge purchase you can put off. If car prices shoot up, a lot of people are just going to wait. Demand is elastic. It's a perfect way to think about it.
So knowing whether to go up or down is amazing. But what if we could do even better? What if we could find the one single price that brings in the absolute most money possible?
I mean, that's the dream, right? Not just to move in the right direction, but to land perfectly on the peak of the mountain. So can elasticity get us there?
You bet it can. And this, right here, is the golden rule. Remember that sweet spot we talked about? The point where demand is unitary? That's it. Your revenue is at its absolute maximum when your elasticity is exactly equal to 1.
So let's take a quick look at another example for a company selling kites. Their demand function is Q equals 400 minus P squared. To find their perfect price, we'd set up the elasticity formula for this function and then solve for the price P that makes the whole thing equal 1. Once you work through the algebra, it simplifies right down to this. 3 times P squared equals 400. And when you solve that little equation for P, you get your answer. $11.55. That is it. That's the perfect price for these kites. Any higher, they lose too many customers. Any lower, they leave money on the table. This is the price that makes them the most possible revenue.
So let's just quickly recap the big ideas. Elasticity is all about comparing the percentage change in demand to the percentage change in price. If your result is less than 1, demand is inelastic, and you should raise your price to make more money. If it's more than 1, demand is elastic, and raising your price is a bad idea. And if you want to find the absolute peak for revenue, you just need to find the price where elasticity equals exactly 1.
And so we'll leave you with this question. This isn't just a math problem. It's a way of looking at the world. So think about a product you buy all the time. Is it an onion or is it a car? And now that you know how this works, what does that tell you about the price you're paying? And maybe the price the company wishes they could charge you?